lovelies, welcome back from break. I hope you had a restful week and that you feel recharged and ready to go. We're going to start with some review of imaginary roots and how we use the quadratic formula to find them, because this week we're going to take our polynomials and we're going to factor them even if they have imaginary roots. So remember, when we have a radical with a negative inside, that's not possible because two numbers multiplied together don't give us a negative number. So when that happens, we call it imaginary. And I just take this negative, I make it positive, and bring my I outside. So what I have now is I root 20. Because if you remember, I equals the square root of -1, I equals the square root of -1, which means that I squared equals -1. Just a reminder of where this comes from, what it means. So I took out that -1 from my radical and I turned it into an I. So now I have I root 20. But I'm not done because I need to break this 20 down. So what can I pull out of 20 that is a perfect square? 4. And that would leave me with 5. The square root of 4 is 2, so that's going to come out. The square root of 5 is not a perfect square, so it stays on the inside. So what I'm left with is 2, again from the square root of 4. I, because I pulled out that negative originally, root 5. So that's how you're going to go ahead and simplify those radicals there. This one's slightly simpler. Again, you take your I right out. Whoop! So now we have -2 I root 100. Well, the square root of 100 is just 10. So now we have -2 times 10 times I, or -20I, as simplified. Okay, if you get something like this, which is what you're going to expect to see after you use the quadratic formula, right? So you factor this, or you use the equation, you get from down here, right? And you end up with something that looks like this. Well, again, if you have a negative in there, you're going to bring your I right out. So now we have 4 plus or minus I root 52 all over 2. Okay, well, what can I take out of 52 that is a perfect square? I could divide by 4. 4 and 13. So now I have 4 plus or minus the square root of 4, which is 2. I root 13, because the square root of 13 is not a perfect square, all over 2. Now, because 4, 2, and 2 are all divisible by 2, I can simplify this fraction down here. And this is going to be 2, 4 divided by 2, plus or minus I root 13. Remember, you have two terms up here and you're dividing by a number. Both terms must be divisible in order to simplify. If only the 4 was divisible by 2, we would just leave it. Or you could divide the 4 by 2 and then leave this part over 2 still. But you cannot just make the denominator go away by simplifying one of the top terms. That's a super common mistake. Watch out for that. Okay, you try that last one on your own. I will post an answer key to this. Okay, for factoring quadratics with the quadratic equation. Hopefully you remember this formula here, but we will go through it anyway. So remember, we get x equals -b. Negative b is the negative of that second term, the term with just an x. So this is going to be x equals +4. Negative 4 makes +4. X equals -b plus or minus the square root b squared. I would put that in parentheses because a lot of people plug all this into their calculator, and if you forget the parentheses in your calculator, it's going to think that that's actually a negative number. So make sure you plug it in with parentheses so it knows you want the positive version, because 2 negatives times each other is going to be positive. Okay, -4 times a times c, both of those are 10, all over 2 times a, which is 10. Okay, so we get x equals 4 plus or minus, you're going to plug this in your calculator, 16 minus 400. Hopefully, actually, you didn't need to do that in your calculator. -384 all over 20. Okay, this is where you kind of guess and check, but I tried 64 and it worked. So 64 is the square root of 8. So this becomes 4 plus or minus 8 root 6. What's left over? Oops, what did I forget? Most importance here, don't forget to take that I out. So we also have an I here. And then all over 20. Okay, so remember when I said we're simplifying, we must be able to divide both terms on the top by a common factor of the bottom. So both 4, 8, and 20 are all divisible by 4, so that's what I'm going to do. So 4 divided by 4 is 1, plus or minus 8 divided by 4 is 2. That I just stays there, square root 6. This is part of that term, so that's why the inside doesn't simplify at all. You've simplified the outside, and that's a multiplication problem, so that covers that. Divided by, well, 20 divided by 4 is 5. And that would be your simplified radical there. Okay, so let's go through what these real, complex, and imaginary numbers are all about. So a real number is most numbers you've experienced in your life. Whole numbers, so, any number like 1, 17, any whole number is going to work. Okay, rational numbers are real numbers, and a rational number is something like 3 over 5 or 0.75 or any number that can be written as a fraction. That's a decimal that repeats as well. So 189 repeating. That is also a rational number. Real numbers also include irrational numbers. So that's things like pi and the square root of 2. Okay, so notice real numbers include basically everything you've ever talked about except imaginary numbers. So let's jump over here and talk about imaginary numbers. So imaginary numbers happen when you square a number and get a negative. Remember, we know that can't really happen in the real world. A negative triumphs a negative is positive. So these imaginaries exist when we somehow get a negative square root. So that we know that I squared equals -1. That's the definition of imaginary number. So we take this I value, we square it, and we end up with a negative. So we call them imaginary. So anything with an I is going to be an example of that. I by itself, 12.212I would work. 3I over 5, -2I plus 6. Oops, not plus 6. Ignore that. That's not a single term. And we're going to talk about that next because that was an example of a complex number. Okay, complex numbers are basically a combination of the two. So a complex number is, let's use a different color. Let's use green for this. So a combo of both. So it's written in the form of A plus B I, right? So it's something like that. So this is a real number, and this is an imaginary number, and we add them together, and that gives us our complex number. So again, it's a combination of the two. So an example of that would be 3 plus 5i. Another example that might confuse you would be 5, because that's the same as 5 plus 0i. So technically that's a complex number where the I term is being multiplied by 0. So on that note, then 3i is also a complex because the a part of that is just 0. So complex numbers are either imaginary numbers or real numbers or the combination of both of them. Hope that helps. Miss you guys.